To determine L, E and V out, if we are given the inductor current and voltage graphs, we have to proceed as follows. The VI relation of an inductor is V is equal to L di dt. Therefore, we need di dt and we need V in order to determine L. So the di dt during this period here, where the switch is closed in the buck regulator, we can determine the di dt, and the di dt is equal to a change from 0 to 2 amps, gives us the di, and a change from 0 to 0.3333 milliseconds gives us the dt. So it is 0.3333 times 10 to the power minus 3, and that is equal to 6,000,6. The di dt during the time when the switch is open is given by is given by 0 minus 2, since the di, the current starts at 2 and goes down to 0, divided by, and the time is 0.6667 milliseconds, and that will give us 3003 for the di dt. Since we now have the voltage and we have the di dt during the time that the switch is closed, we can determine L. So L is equal to V divided by di dt, and that is equal to 10 volts, and the di dt is 6,000,6, and that gives us an L of 1.6665 millihenry. What we also want is E and V out. So our buck regulator in mode 1, that is when the switch is closed, is given by this circuit diagram, and that is V out, and that is V inductor, and this is E. This is during mode 1. During mode 2, the switch is open and the diode is closed, which now puts our inductor in this position here like this, since the diode was in that position there. And we have the capacitor there, and we have that same capacitor here, and we have the load. There we have V out. Now the inductor indication of inductor voltage cannot change, so this stays V inductor, the direction. But during this time, we see that the inductor voltage is minus 5 volts. And since this arrow is pointing down and that arrow is pointing up, it means that V out is equal to minus 5 minus 5 minus 5 volt. This minus is due to the fact that there's 180 degrees phase change with the arrows, one going down, other one going up, and the minus 5 is the inductor voltage that we got from the graph. So here we now know that V out is 5 volts. So we can write there that V out is 5 volts. Now, according to Kirchhoff's voltage law, the sum total of the volt drops in a closed circuit is equal to the applied voltage. So E is equal to V inductor plus V out. And V inductor, from our graph during the time that we are busy with mode 1, here's mode 2, is 10 volts. So then it is equal to 10 plus 5 is equal to 15 volts. Thank you.